my name is Ron. I'm a software engineer at Bolt, and today I'm here to talk to you about elastic systems, namely elastic through and through, from 0 to 11, then all the way back down. For the agenda, we'll focus on why there's more to scale than just up, hence the title, from 0 to 11, but all the way back down. And then we talk about how serverless can help with these kinds of issues. Then analyze some common patterns that are used with this set of technologies. We'll do a quick demo just to see some things working and finish up with some closing thoughts. So why is there more to scale than just up? I know, and myself included, we like to dream that our application will be the next big thing and will be massively used and need to scale. But there is also situations where scaling down is just as important. And this all comes down to system characteristics, namely the usage patterns of our application. So we may have applications that have occasional access, or maybe inconsistent or spiky loads, or even we have no idea what is the usage patterns that we'll have in our application in the future. So in any of these cases, scaling down can be beneficial. And just to give you some examples of these kinds of patterns, imagine an internal application that's just used an hour a day, maybe, like, for example, a time reporting application where users don't really go there too much until they need to report their time. And in these cases, is very occasional access. Maybe we have an online store which has some access, nothing groundbreaking, but then comes Black Friday and it's no longer moderate access, is massive access, so a spike in load. Or maybe we are creating a new mobile application and just trying to bootstrap the user base, so we don't really know what will be the usage patterns. So we need to be able to scale down to 0 to be cost effective. So in all of these cases, elasticity is a win. And as I mentioned, scaling down can provide massive cost benefits. But on the counterpoint, scaling up is still important to provide the best user experience, because we don't want the users to, when there is a spike, we don't want the users to give up on using our application. We want them to be able to use it. And I hope someone gets this reference to this old school movie. Well, they have the ability to go with their amplifiers from 0 all the way to 11. So in this context of scalability, elasticity, serverless is a set of technologies that can be very helpful. This is not a new paradigm. Cloud providers have multiple offerings already in this context. We have things like functions as a service, where you can just write some code and push to the cloud to be run there. We can use message brokers to implement our event-driven architectures and other asynchronous processes in the background in the cloud. We can use databases with consumption-based plans. So instead of having to pay for a database to just sit there doing nothing, we pay for the storage, of course, but then pay for the compute used by the database. When it's not being used, we just pay for the storage. And also, we can have AI, machine learning, and other kinds of APIs that follow the same consumption-based plan, where we pay when we use them. And there's a lot more stuff that we could talk about, but there's just no time. So the thing that all of these have in common is that when the system is idle, the cost is 0. And I put the asterisk because storage has costs, even if idle, but compute really doesn't. So we will pay for the database storage, we will pay for the assets, like images that we store, but we won't pay for compute, so for CPU, when it's not being used. Also, I'm focusing this presentation on scaling, but there are other benefits to serverless, like simplified development models, like functions as a service, where, like I mentioned, we just write some code and push it to the cloud. No need to worry too much about frameworks and stuff like that. Also, simplified infrastructure, because this is serverless. There are still servers, but we don't need to care because the cloud provider handles everything, namely keeping the servers up to date and secure, and we focus on writing code for business logic to provide value to our application. And of course, like I mentioned, the AI, machine learning, and other APIs and services that we can use to enrich our application without needing to do a lot. The cloud providers have a lot of options, so we can just take a look and create more powerful applications without so much effort. So in the context of these serverless technologies, there are some common patterns that we can observe. Starting with a simple but powerful one, it's the single page application and serverless API, where we implement a single page application, so HTML, JavaScript, CSS, and all that stuff. And we push a lot of the computing needs to the client, but we can enrich the application by creating a serverless API. In this case, this is an example using functions as a service, but there can be other things that we can use. But the point is we enrich our single page application by pushing these kinds of things. If we can push as much as possible to the client, the better. So we are saving on our costs in the cloud. So, of course, that was just a very simple example, and things will get more complex. Like the single page application, as soon as we need authentication, we can, for example, use an authentication provider. We can use an API gateway to enforce that authentication and add other things on top, like throttling and protection against attacks, stuff like that. So think of this like the starting point, but then it will get more complex. Also wanted to mention that other related things like the Jamstack, so JavaScript APIs and markup, is something that's very hyped in the last couple of years, which pushes this single page application and APIs to the most possible things that we can do on the client, as much as pre-rendering things so at build time, so that as much as possible we'll use static assets. And then when we need to enrich our application, then we use those APIs. Also, I focused on single page application, but of course there can be variations. Like it doesn't need to be a web application. It can be a mobile application. And for sure, in the some years ago, when there was the boom to create mobile applications, it would be great that serverless already existed, because sometimes to build that mobile application, we need something from the server, and maybe the mobile developers don't have a lot of experience on the backend. So being able to use functions as a service, for example, to implement those APIs would be great. And of course, desktop or all of the above. So we can create a single page application, mobile, desktop, and have a great client-side experience and push a lot of other things that need to be on the server. So this is, like I said, this is just a simple pattern that we can build upon. In terms of message-driven applications, it can be, of course, mix and match with the previous one, but in this case, we are focusing on asynchronous communication between our cloud components. In this case, again, I'm using functions as examples, can be other things, and we use those message brokers to pass messages between them and eventually implement event-driven architectures where when something happens, an event is published and the other functions may react, do something, maybe send an email, store something in the database, and so on. So we can also, like I said, mix and match, not only those patterns, but even imagine that we have an existing traditional server-side rendered application and we don't want to get rid of it because it works well, but maybe we can implement some things on the side and take advantage of these serverless technologies. And that's what we're seeing here. We have the application, and we use messaging and functions to do something else. Also, this can be used as a modernization path. So instead of a big bang rewrite, which brings in a lot of risks, we can start extracting features from our traditional server-side application and push it to these new serverless technology one step at a time. Don't need to do everything at once. So let's take a quick look at the demo. which is a serverless OCR, so optical character recognition, where we push an image to our API and get the text that is written on the image. So we are using that basic pattern with a twist. So we start with a single page application implemented with Vue.js and Azure Static Web Apps. The API is using Azure Functions and C#. The twist is that instead of a database, we use cognitive services to computer vision API to recognize the text in the image. So this is the example application, very simple. We just choose an image, push it, and of course this would happen in a demo. But it's done. So it was able to recognize the text that I pushed in the image. And using these kinds of technologies, like I said, that this part, which might be interesting, is using cognitive services. This has a lot of features: speech, language, vision, decision. I'm focusing on vision, computer vision, to analyze the image and extract the text. In terms of the application, we can take a quick look. We have 4 folders. So we have a GitHub folder where you have the automated deployment plan. So it's not serverless in particular. It's just modern good practices to not do things manually, to deploy things automatically. So I have a GitHub workflow, which besides deploying the application, also creates the infrastructure using these ARM templates. So this ARM template declares the services that we want to use in our cloud provider, in this case, Azure. So if we take a look here, what is declared in this file is what we see over here. So we have the cognitive services, the application insights to monitor our application, and the OCR static app to see where we host both the functions and the assets for the Vue.js application themselves. As for the deployment, can be interesting just to take a look that we can do everything in here automatically, like log into Azure, create a resource group where we'll put the Azure resources, deploy the ARM template to the resource group, and finally build and deploy the static app as well as its corresponding API. Just taking a quick look here, we have a backend. A lot of boilerplate, ignore that. But we go here to the function. Again, a lot of C# boilerplate. And we can see that is a function that is triggered by HTTP request using a post. The route is /API/OCR, so API is always a prefix. Take consideration that I'm not doing anything. This is not production ready. I'm not doing validation or error checking, but still good enough for this quick demo. I'm just getting the file from the form using the computer vision client and getting the recognized text so we can return it to the client. So simple in general, a bit more boilerplate than needed. In terms of the front end, it's again a typical Vue.js application. Most interesting thing probably is this uploader, which has a single input that on change calls the upload function. And this function simply calls the /API/OCR, pastes the post data, and gets the recognized text, which is then pushed into the text box. So this is a very quick demo. If you're interested in these kinds of things, but even more complex and more interesting, you can take a look at this MCW serverless architecture from Microsoft, where there are a lot of more things in use. Again, Azure Functions, cognitive services, but also Event Grid, Cosmos DB, and I don't know, application insights that I'm using, but I didn't show you anything. So this can be a very interesting example. So take a look for MCW serverless architecture in GitHub. But just to wrap up with some closing thoughts. one of the main things I want you to take from this session is that depending on the usage patterns, scaling down to 0 can be hugely beneficial. We can't focus just on scaling up. Scaling down is also important. And there are various options with different characteristics. I focused in these examples on Azure. So we have some compute examples here. Azure Functions was the one that I used, which is probably the more simplified one to get started. But if you need to get a bit more complex, you can, for example, use Azure Container Apps, which instead of packing a single function or a single set of functions, you can pack a whole container, so you can do more complex things here and use whatever kind of technology you want as long as you can put it in a container. You can also take a look at Kubernetes and KDA. So KDA stands for Kubernetes Event-Driven Autoscaler. Azure Container Apps uses KDA behind the scenes, but abstracts it for us, which is rather nice. But if you need full control on this, you can go in Kubernetes KDA and do everything yourself and achieve the same kind of benefits of scaling all the way up, all the way down. Now, another really important point that, even though I've been talking a lot about this serverless thing and stuff like that for the elasticity and scaling down to 0, you should keep in mind that for more consistent loads, where you know that you will always have this load, serverless can become costlier. So make sure to use the pricing calculator. So the cloud providers use them, and you can take a look at if your application, depending on the load, works well for that load. Maybe it's cheaper than going into the serverless where you pay for example, using a HTTP trigger, you have the number of requests and not just having a thing up. So it can become costlier. So make sure to use those pricing calculators. And also, even if scaling all the way down isn't important, elasticity can still be beneficial. So PaaS offerings also provide auto-scaling features. For example, Azure App Service does offer these auto-scaling features. They are just not as granular, so not as powerful as functions, container apps, and so on, but you can still auto-scale. So make use of that, even if you don't scale all the way back to 0, but you can scale down, and when you have a traffic spike, you can scale up. And I think that's mostly it. So thank you for joining me. Feel free to reach out to us for partnerships, and if you need help doing some of these things, you can reach out to my colleague Joana Salvado. If you want to geek out about these kinds of technologies and talk about this session, feel free to reach out to me by email or even Twitter, as you prefer. So thank you. See ya.